Welcome to This Explainer. I am absolutely thrilled you're here because today we're diving into a topic that is just genuinely mind-blowing. When you look up at the night sky, it looks incredibly peaceful, doesn't it? Very quiet. But the truth is, the universe is an incredibly noisy place. It's buzzing, humming, and flashing with all this invisible energy. So today, we're basically going to act as cosmic detectives. We're going to put on our headsets, look at some seriously astounding data, and try to solve some of the most fascinating mysteries hidden deep within the radio signals of the cosmos. But that immediately brings us to a pretty fundamental question. If the universe is out there speaking to us, why is it so incredibly hard to hear? Well, space is literally filled with radio signals. Deciphering them isn't exactly like tuning your car radio. It requires this crazy mix of sheer luck, precise timing, and rapidly evolving technology. You practically have to be pointing your dish at the exact right spot in the sky at the exact right millisecond just to catch these fleeting whispers in the dark. Okay, let's dive right into this. Just look at this number. Over 500. For years, capturing these signals it was literally like finding a needle in a cosmic haystack. Since their initial discovery back in 2007, astronomers had only managed to catch about 140 of them total. But then this massive telescope in British Columbia called CHIME was turned on. And in just its first year of operation, it detected over 500 new fast radio bursts. In a single year, we nearly quadrupled all previously known discoveries. This sheer scale of noise completely changes the game. So, here is our Cosmic Detectives docket for today's explainer. First, flashes in cosmic darkness. Second, catching fast radio bursts. Third, the 22-minute mystery. Fourth, revisiting the WOW signal. And finally, the universe is speaking. All right, part one, flashes in cosmic darkness, the sudden outbreak. We're talking about fast radio bursts, or FRBs. These are oddly bright flashes of light in the radio band that blaze for mere milliseconds before completely vanishing without a trace. But what makes them our prime suspects in this cosmic mystery is their sheer brightness. It means they are punching through from incredibly distant extragalactic origins. They blaze into existence for a fraction of a second and then, poof, they're gone. They leave us with these isolated data points originating from incredibly energetic yet entirely unknown sources across the universe. Now here's where the plot thickens. The data actually reveals a critical distinction. Our suspects fall into two camps, one-offs and repeaters. Out of the hundreds found, scientists noticed a handful of sources that burst repeatedly. And here's the crucial clue. The repeating bursts actually look different. They last slightly longer and emit more focused radio frequencies than the single one-off bursts. This strongly suggests to our detectives that these aren't just variations of the exact same thing. They likely come from entirely different astrophysical mechanisms and sources. So how exactly are we suddenly catching so many of these distinct signals? Moving right along to part two, catching fast radio bursts, a stationary net. Traditional radio astronomy usually involves swiveling a giant dish to focus on one tiny part of the sky, right? But the CHIME telescope is completely different. It's made of four massive half-pipe antennas that just stare entirely motionless at the sky. Using some seriously heavy-duty digital signal processing, CHIME looks in thousands of directions simultaneously as the Earth rotates. Thanks to this stationary net, scientists calculate that a staggering 800 FRBs flash across the entire sky every single day. And it gets better. By measuring how these signals disperse as they hit interstellar plasma, astronomers are now using them as actual probes to map the distribution of gas and matter throughout the entire universe. Which brings us to part three, the 22-minute mystery, the pulsar that forgot to die. Okay, let's slow things down. Let's transition from milliseconds to minutes to investigate our next major anomaly. Meet GPMJ 1839-10. It's located roughly 15,000 light-years away in the constellation Scutum. Now, while it was formally discovered in 2022 by the MWA telescope in Australia, the detective work revealed something absolutely fascinating. When astronomers took this new profile and looked back through historical data with fresh eyes, they found it had been pulsing consistently in archival data dating all the way back to 1988.
It's been active for over 3 decades without slowing down.
And the real kicker here is this astonishing number, 22 minutes, or exactly 1,318 seconds. This object emits periodic bursts of radio waves every 22 minutes, with the pulses themselves lasting up to 300 seconds. Why is this a huge deal? Because it completely breaks the rules of physics as we understand them. Typical isolated neutron stars spin much, much faster. If they spin this slowly, they fall below what astronomers call the classical death line. That's a threshold where they simply shouldn't have enough rotational energy to emit radio waves anymore. And yet, this object is just loudly pulsing away. No way, right? This has obviously left scientists proposing competing hypotheses to try and explain the impossible. On one side of the table, we have the neutron star magnetar scenario. This suggests it's an ultra-long period, highly magnetized, dormant neutron star that is somehow sustaining emission through unconventional processes we just don't fully understand yet. On the other side, we have a highly favored recent model from January 2026, a white dwarf pulsar. This model argues it's actually a white dwarf in an 8.75-hour binary orbit with an M-dwarf companion. In this setup, the radio emission is triggered when the white dwarf's magnetic axis sweeps through its companion's stellar wind, neatly avoiding that deathline problem entirely. It's a fantastic cosmic showdown. But from that ongoing debate, let's shift gears to the ultimate cosmic cold case. Part 4. Revisiting the WOW signal. Time to reopen the cold case. August 15, 1977, the Big Ear Telescope in Ohio detects a massive 72-second blast of radio waves that was never heard from again, the WOW signal. It became completely legendary. For decades, the only real clue we had was this messy, original continuum analog record. Investigations totally stalled out because the data wasn't fully digitized, leaving researchers to basically guess based on a few famous printouts. But recently, dedicated volunteers have actually recovered decades of previously unpublished raw Ohio SETI data. By applying modern forensic tools to this old data, researchers have finally been able to reopen the file. And this is where it gets incredibly cool. When those modern forensic tools plotted the recovered data, they produced this beautiful, precise Gaussian model fit. This right here is the smoking gun. It proves the signal perfectly matched the antenna's beam pattern, meaning it moved exactly like a distant, stationary object in the sky as the Earth rotated. The new analysis revealed a massive signal-to-noise ratio of 30.1 and pinpointed an incredibly specific frequency, 1420.726 megahertz. With this sharp new data in hand, researchers started rigorously eliminating earthly suspects. Was it a satellite? Nope. No known satellites in 1977 fit the required orbit to be in that specific spot. Was it the sun? Actually, records show extremely low solar flare activity that week. What about a harmonic from an old television broadcast? The analysis proved there were absolutely no UHF TV harmonics operating in Ohio at those required frequencies. In fact, calculating the odds of random terrestrial radio noise creating this perfect 72-second Gaussian curve, it yields a 1 in a billion chance. Since we can pretty safely say it wasn't terrestrial, the investigation leads us to a refined, narrowed origin field on the map. Thanks to the new data, scientists calculated that the peak flux density was actually much higher than previously thought, over 250 Janskis. To put that in perspective, that is an absolute roar in radio astronomy terms. It strongly suggests a natural astrophysical origin. Based on that 1420 megahertz frequency, which is the hydrogen line, scientists are now heavily investigating if it was related to small, cold, neutral hydrogen clouds, or maybe some incredibly rare maser flare. The cold case is finally heating up, guys. And that brings us to part 5. The universe is speaking, closing the files. We've gone on quite a cosmic journey today, from a sky literally flashing with 800 fast radio bursts every single day, to a bizarre pulsar entirely defying the physical death line, to finally shedding new light on the legendary WOW signal. All of this highlights an incredible truth. Humanity's ability to listen and re-listen to the cosmos is unlocking secrets we honestly never thought possible. But perhaps the biggest takeaway for us today is this:
As our hearing improves with better technology and software, what hidden messages will we uncover in the data we already have? Some of our greatest cosmic discoveries might not actually come from building bigger telescopes to look up, but from meticulously looking back at the archives. The universe has been speaking to us all along. We just have to be willing to really listen. Thank you so much for joining me on this explainer. Keep your curiosity fired up, and I will see you next time.